Hello guys, Art-Teeves here. This is a fully narrated video that covers the process of modeling, UV unwrapping, baking and texturing a simple Topology flower prop. I model it in 3ds Max 2024, unwrap it in RizomUV, bake and texture it in Substance Painter. The turntable you see was done in Marmoset. Let's get started. First of all, a few words about the model itself. I wanted to demonstrate the core principles behind modeling objects like this, but the polygon count ended up being fairly high, 734 polygons and almost twice as many triangles. That's not really a problem, especially if we're talking about small scenes for indie games without perfect optimization. I unwrapped the model using a 1K UV map. Of course, when you are modeling several plants for the same game, it's best to use a single large texture atlas instead, ideally a 4K UV map with 32 pixels of padding. This is beneficial because it allows us to make the most efficient use of all the available texture space, instead of wasting a certain percentage on each of 4 separate 1K maps. During modeling, I used the Loop Regularizer plugin. Overall, I could have achieved the same results using rapid tools. I didn't use sculpting and created the high poly model from the low poly one using Turbo Smooth. The video is sped up by 2.5 times and I didn't remove any critically important parts. That said, I did cut out some boring segments, since I was modeling without references and didn't want to waste viewers' time in places where I later changed things anyway. If this speed feels too fast for you, you can always slow the video down in YouTube's settings and rely on my subtitles. I left a table of contents in the video description, as well as in the pinned comment. In addition, I didn't get a bake I was happy with on the first try. Not all adjustments made it into the video, but the general idea was as follows. Besides what you see on screen, I tweaked the shape of the high poly model so that its outer contours were as close as possible to the low poly version. The thing is, the high poly was created using 2 iterations of Turbo Smooth, but I didn't want its contours to become too thin, so I manually expanded them. Also, at first I thought I didn't need to add caps to the inner cylinders. That was a bad idea, so I added caps, then detached them from the rest of the model and baked each of them against itself, so that no baked geometry from the plant stems would affect them. Anyways, let's go step by step. The first step when creating tubular objects like this is to figure out whether you actually need tubes at all. The point is that when we model flowers or similar assets, we try to save as many polygons as possible. Ideally, stems should have no more than 3 to 5 sides, definitely not more, unless we're dealing with a super important object that the viewer will watch closely and from different angles. So, what's the problem here? The issue is that our tubes need at least 5 sides, and also a sufficient number of horizontal supporting edge loops, so that they have at least some degree of smooth curvature. Without that, they'll look angular. More classic flower shapes are much easier to paint and take up significantly less space. The second question is about scale. What size do we actually need these flowers to be? If we're talking about very small objects, it's probably easier to paint most of their details instead of modeling them. For example, instead of modeling and baking the internal geometry of the flower, we can simply paint dark indentations on the top caps of our tubes. If, on the other hand, we're creating a large object at the character's height, it will need far more than 5 sides. The larger the cylinder, the more sides it needs to achieve decent looking shading. Let's go through everything in order. I started modeling the flower by creating a composition out of simple splines. Later I applied a 5-sided loft modifier to each spline. I edited the curve of each loft so that it widened toward the top, and I also gave different lofts different sizes. Ideally, the tallest ones should also be the thickest. I cut out a small part of the video where I kept applying loft to new splines over and over until I arrived at the final shape. The next step was to combine all loft objects into a single structure, a single object, convert it to editable poly, align its base so that none of its elements were floating in the air relative to the others, and remove unnecessary supporting edge loops to reduce the polygon count. After that, I rotated the tubes and connected some of them in pairs using inset and bridge. I cut out part of this process to save viewers time. Overall, this is the most time-consuming stage, because we're trying to achieve a visually pleasing composition. You shouldn't create too many intersections. Polygon count increases very quickly because of them. Once I was happy with the final low poly shape, I applied Turbo Smooth. At this stage, it's a good idea to save a backup of your file. just in case you later decide to start over if you don't like the result. TurboSmooth turns 5 sides into 10, so it makes sense to keep its results only where they actually look good. All other edges should be removed or reduced. Our method here is fairly primitive. We remove unnecessary edges using ring select and collapse, and then, from time to time, we restore edge loops to perfect circular shapes using loop regularizer. Since we're dealing with relatively low poly plants, we can use triangles, especially in the lower part of the model, but not at the top, where they would affect shading. I used single chamfers at the top of each tube. In principle, this could be avoided, but I felt the model looked nicer with them. Our goal at this stage is to remove all unnecessary edge rings and edge loops and keep only those without which the model would noticeably degrade. I methodically go over the model again and again, selecting unnecessary edge rings and collapsing them. Some vertices I move with edge constraints enabled, while others I connect using the target weld tool. The composition can be adjusted during the process, for example by rotating the tubes and switching the coordinate system to local. If we want to reduce the number of supporting edge loops, we can insert new ones between existing loops while holding the Shift key, so that 3ds Max respects the existing edge flow, and then remove the excess faces. Once you rotate all the tubes you want and get the desired shape, make sure to check its bottom part again and align all bottom parts to the same height so nothing is left hanging. If we want to extend a tube, we can select its top faces and pull them out while holding Shift to create new polygons. For this to work correctly, it's important to switch to local coordinates. Sometimes the angle will still be off. In that case, we can temporarily create an edge cap and pull it in local coordinates, or apply extrude or bevel to it. In general, we want to preserve the highest level of detail around the bridges that connect different cylinders. These are the areas where shading suffers the most from polygon reduction. I add an extra edge loop in the middle part of some bridges and scale it down to give them some nice looking curve. It may not be a good idea if you try to stick to a very low poly count. When I collapse edge loops, the shape of the cylinders obviously changes, so in some cases it's a good idea to manually adjust vertices to stabilize the forms. Most of the time, I move vertices with edge constraint enabled. I align the cylinders and turn them back into clean circular shapes using loop regularizer. Overall, we're not aiming for perfectly clean geometric forms. On the contrary, slight irregularities can add a certain character to our biotubes. At some point, I align the top edge loops of each tube. This is a good moment to make a decision. We could paint or bake some indentations and dark cavities into them, or proceed the way I did. It's important to save as many polygons as possible on shapes like these. We don't need detail in places the viewer will never notice. As I mentioned earlier, each tube receives a single chamfer on both the outer and inner sides. I'll speed up this part of the video a little bit, as nothing new happens here. I simply move vertices around while having the edge constraint function enabled, and do some other minor adjustments. Then I create inner cavities for each tube. You can either do it by applying the shell modifier to them, yet you'll most likely want to remove all new geometry made by it except for the top sections, or rely on polygon modeling. I relied on polygon modeling. I only added a single top edge to each tube and a single inner section. Apparently, in this video you can see that I have left those inner parts uncapped. In fact, that was a mistake that got fixed later. Thinking in retrospect, maybe it would be a much better idea to simply bake and paint small dark cavities in top caps of each tube instead of adding all that new geometry. In order to bake those inner caps that were added outside of this video properly, I've separated them from the rest of the model and baked each of them onto themselves. The final thing I did to my tubes was give them top chamfers, a single smoothing group, and the weighted normals modifier. A single smoothing group is essential because the process of baking will transfer the smoothing group data from the high poly model. I added a lower hemisphere to this model in order to demonstrate the process of shaping objects like this, objects that you can later paint on during the texturing stage, or bake something interesting onto. Looking at the model now, I'm thinking that instead of a hemisphere, a concave inward shape that follows the flow of the tubes would have been a better choice. On it, I could have depicted a web-like structure or some kind of organic pattern inspired by the alien hive aesthetic. The polygon count of the high poly hemisphere doesn't really matter, the main thing is that it shouldn't be too low. I create auxiliary spheres, place them in the required positions on the hemisphere using Object Paint, and then cut them out using Probuline. After that, I apply several iterations of automatic retopology to the sphere until I'm satisfied with the topology I get. I played with the shape of the hemisphere using the Spherify modifier. I also gave it thickness with the Shell modifier and smoothed it using TurboSmooth. The number of iterations can be anything, since we are going to bake the high poly hemisphere onto the low poly one anyway. At this point, we can play with the size of each hole and the target poly count of our automatic retopology. We can also experiment with the shell's thickness and the amount of TurboSmooth iterations. Finally, if we only want to paint on this hemisphere, we might ignore all these steps and simply paint over it later. Mind that baking these holes will obviously require a cutout or a transparency map. Finally, I create a low poly hemisphere and match its shape to that of the high poly hemisphere. The LP hemisphere doesn't need more than 8 sides, anything more would be excessive. The key point here is making sure that the shapes of the LP and HP objects match closely, so that they don't diverge too much from one another. First, I feed the low poly sphere with 8 sides to the dimensions of the high poly sphere, so that it intersects with it and slightly extends beyond it at the bottom. The key thing is to avoid the LP sphere lagging behind the HP sphere. The easiest way to feed the hemisphere is by using the FFD modifier. As for the tubes, I simply duplicate their low poly version, rename it to the high poly version, and apply several iterations of TurboSmooth. Before doing that, it's a good idea to expand the top faces slightly, so that the smoothing from TurboSmooth makes them take on almost the same shape that already exists on the LP model. Otherwise, they may extend beyond it, which is something we want to avoid. The ideal case is when the position and contours of the HP and LP models match almost perfectly. As I mentioned earlier, I didn't show this in the video, but I added caps to the inner edge loops of our tubes. To prevent anything unnecessary from being baked onto them, I simply detached them from the model and baked each one against itself. Once we see that the LP and HP versions are very close to each other, we should check the LP objects for angons and other geometry we want to avoid. In addition, it's worth using the XView tool to make sure that there are no isolated or overlapping vertices or unwanted open edges. In the case of isolated vertices, we can either select and delete them or attach our object to another one, for example a newly created cube, and then simply delete the cube, which is exactly what I did in this video. Finally, we want to group everything together, place our group's pivot point to the center of its bottom part, and move our composition to 000 scene coordinates. Next we want to make sure that our LP objects are smooth. They get their smoothing group data from our HP objects, and also make sure that our LP and HP objects share their pivot point locations. For more complex objects, we may want to reset their scales, rotations and X-forms. You may also want to apply the weighted normals modifier to your model. I unwrap my model in RizomUV, and I do it in a fairly lazy way. In general, you can unwrap a model like this in any suitable software. The only thing I don't recommend is doing it in Max, unless you have some specialized paid plugins. And even then... Overall, at the texturing stage we'll be using triplanar projection, so our seams won't be very noticeable. Still, we want to maintain consistent textile density, and we don't want objects to differ from each other in terms of UV chunk scaling. There's also no real reason to align the unwrapped cylinders perfectly. In practice, I simply cut the cylinders along their inner sides, preferably along edges that terminate at the bridges between cylinders. Even if some seams end up being visible, that's not a big issue because their placement won't allow viewers to actually notice them. In general, I use a double click to select edge loops and the C key to cut. Other useful hotkeys are W to weld, U to unwrap, O to optimize, and Ctrl plus page down to rotate by 90 degrees. I align all cylinders vertically. You can align the horizontal bridge cylinders horizontally. This can later be important for certain grunge effects in Substance Painter. We want to give the lower hemisphere a fairly large area on the UV map. The reason is that if we end up painting something on it, We want it to look decent and avoid blurry edges. After that, I simply pack my UV chunks. As I mentioned earlier, if you are working on props for your game, you should group several models onto a single 4K Reza texture atlas. This allows you to make the most efficient use of the available texture space. At this point, I still haven't added those inner tube caps. Those were added off camera and then integrated into this very UV map, distributed in some remaining spaces. When baking my model, I chose the highest possible amount of rays on all tabs, selected my HP object in the corresponding menu, switched my ambient occlusion baking settings to the same named meshes only, and switched my subsampling to 16. I also disabled the ID section and enabled opacity 1. At this point, you may want to run the process several times, and play around with your maximum frontal and rear distances until you get the result you want. Obviously, model parts name suffixes shall match both in 3ds Max and in Substance Painter for things to work correctly. As you can see, I have some dark areas atop some tubes, which were fixed during the rebaking off camera. I didn't want to record all attempts. The only advice that works here is to actually make sure that your HP and LP objects' borders are located really close together. In order to activate transparency, I go to the Shader Set Settings menu and set my shader to PBR Metal Rough with alpha blending. Next I enable the opacity channel for my model. Finally, I create an opacity fill layer, apply a black mask to it, and fill my model with its own opacity map generated by baking. There might be some anomalies that you can see in the bottom part of our lower hemisphere, so I send my opacity map to a different folder, mask the folder, and only unmask it to some parts of the model I'm satisfied with. We can also create an opacity layer, mask it, and use the Follow Along Path tool to paint opacity wherever we want it to be. For tubes, it is really important to texture our cylinders the way their seams aren't visible. To achieve this result, we can set the projection methods of all our layers and grunges to triplanar. Main tube linear details come from the anisotropic noise grunge applied to a simple fill layer. Each new layer brings color, roughness and height details. To make our material look cartoony and stylized, I add a blur slope filter to it right on top of the anisotropic noise fill. The organic components come from another fill layer that gets the black mask and a grunge map 005 fill applied to it. It also gets covered by the blur slope filter. Next, another fill layer is applied to our tubes that gets a Dirty Leaks preset smart mask. Make sure to change its projection method to triplanar. You can also play with its styling at any point. I don't care much about colors at this stage. We do some kind of a color blockout and then tweak all colors manually, bringing them all together. In order to add some edge highlights, I've made a bright fill layer, applied a mask editor to it, and played around with its curvature settings. Next, I've added two gradients to my model. The first one comes from a fill layer with a ground dirt smart mask applied to it. The second one got a 3D linear gradient applied to it. Remember to change your lighting and environment settings now and then to see how your model performs in different scenes and in different conditions. I've also made a dark fill layer with a very high roughness value to fill in those inner cavity caps and make it seem like their bottom parts are barely visible. At this point we didn't paint anything by hand, and we retain control over all the opacity layers, their follow along path splines, colors, roughness and height of different layers, and even the tiling and other settings of our grunges. We can return to any layer or mask at any point when we bring our model together or adapt it to a particular project. When it comes to such props, it might be a good idea to make multiple versions of such things, and also make sure that they blend well with the scenery of your project. It is always a good idea to play around with various gradients that make your props blend with the surface below them. Sometimes you can simply achieve this result in game engines, but why not think ahead? I've preserved some footage of me playing around with various colors and grunges that didn't make it into the final prop, just to show you the way you can experiment with simple tools. The hemisphere consists of opacity paint layers, a main fill layer, a fill layer that has a grunge map 005 and a blur slope filter applied to it, and also a fill layer that has a grunge map 31 applied to it. The interesting part here is that we could have actually skipped any opacity baking and simply paint our hemisphere with a masked fill layer. To give painted holes some volume, we could have played around with the fill layer's height. I've also set the projection type of this layer to spherical and played a bit with its styling. I've cut out some parts of the video where I paint the opacity spots on the hemisphere and pick colors for each layer, slowly bringing them together, making them match each other. I wasn't using a reference image, so this process took some time. Since our model has some obvious UV seams, it might not be a great idea to use some of the new Substance Painter tools on it, including the Stylization tool and the bevel filter. Those will require us to conceal many seams manually by using the classical method involving the clone stamp tool. In fact, such props work really nice when there are many versions of them, including both different models and perhaps different texture sets for the same model. Obviously, it's a lot easier to bring together some dark and dim colors, matching bright ones is much harder. The sphere definitely needs some gradient to blend with the surface and also some roughness adjustments. Now that I think of it, we could have made it a simple cone, and then possibly paint some stylized spider webs on it, or some alien hive-like things. Finally, I check my model under different lighting and environment conditions again, bring its colors together, and make Hemisphere match tubes properly. I throw in some extra grunges just to polish things a little bit further, add some dirt to it, because, well, dirt is cool and makes stuff look more natural. And basically this is it. I think this covers everything I wanted to mention in this video. Thanks for watching, guys. If my videos are of use to you, please be my guest and subscribe to my channel for more stylized content. And most importantly, have a great day.